Now in lesson 3 of chapter 1, again, following that protocol, take a look at this. Is this a polynomial? And the answer is no, it's a non-polynomial. And you might say, why? Because the exponent is in fractional form. You can't have fractional exponents being a polynomial. And again, fractional exponents are radicals. You can't have variables that are under radicals being a polynomial. And you can't have variables in the denominator or negative exponents on variables in the numerator. Okay, these were all summarized in our flipped classroom lesson. Now, going on to item 2, we want to have a strategy for combining like terms where this is a subtraction. Keeping in mind when there's a negative sign in front of a parenthesis, we remove the parenthesis, just change all the signs. So if there's just parentheses, we can just remove it. So putting them in like term columns, negative 6y to the third. I'm going to put my positive 2 over there. And I have a negative 9y. So as I change the signs and remove the parenthesis, this is going to be a negative 14. So I'll put that in this column. This is going to be a positive 5y. This column. This is going to be a negative 4y to the third. So now that they're in like term columns, it's just a matter of adding them up. A negative 10y to the third minus 4y minus 12. And that is the answer. Now, this was just a basic review of many of your algebra skills. Here we're going to factor this now. The protocol was look to see if there's any common factor, which there isn't. Then put 2 sets of parentheses and undo the FOIL. Well, this would be an x and an x. And then factors of 28, that is to a 3, depending on our signs here. So a 4 and 7. And we need a positive, so our outers would need to be positive. Our inners would be negative. And then we FOIL it to check. X times x is x squared. My outers a positive 7. My inners a negative 3. Negative 4 that add up to a positive 3. All right, that looks good. Now in example 5, we're to factor this by grouping. And again, lots of technique here. We want to see if we can take something out of these first 2 terms. And as we look at it, I see we can take an x out. And we get a minus 2b. And what can we take out of these? Well, we can take out a plus 2y. And then we are left with an a minus 2b. So now we have 2 terms, and they each have the same binomial factor. So we put that factor in one parenthesis, a minus 2b. And then in the other parenthesis, what was left? The x and the plus 2y. And then reviewing, if we had this, the way to multiply it is you take the x multiplied by this binomial, and then the plus 2y multiplied by this binomial, and then distribute, and you get what they start off with. So you can go one way or you could go the other way. All right, let's go on. Part of factoring is the art of looking at something and see what you see here. Well, this is a perfect square, this is a perfect square, and there's the negative between them. So this is the difference of perfect squares that will factor into its conjugates. Take a moment, see what you get. Well, y plus 8, y minus 8. Okay. Number 7, factor this trinomial. So looking at it, again, no common factors, so two sets of parentheses. Now 5 is prime, so we know this is going to be 5x and an x. 3 is prime, so it's a matter of putting the 3 there or there. If you put it there, you're going to get a 15 for the outers, so that's no good. So let's try it there. Now our outers are 5x, inners are 3x, the difference is a 2x. We need a negative in the middle, so the outers will be a negative, the inners will be a positive, and when we FOIL it, we actually get this. So this checks. Now here they're asking us to FOIL, so we'll do it together. Outers 2x to the 4th. That was first, I should say. Outers now, a negative 12 x squared y. Inners, a positive 1 x squared y. Normally we don't write the 1, but for calculations, that's okay. And then last, a negative 6y squared. Now our two middle terms are like terms, so we get 2x to the 4th, and then doing our calculation, a negative 11x squared y, and a negative 6y squared. Again, there's art in this. As we look at example 9, what do we see here? Well, we have x to the 3rd plus 8. Now, this is the sum of perfect cubes. So to review that protocol, that will factor in something that has two terms with this sign into something that has three terms where the middle term is going to be the opposite sign. And then we take the cube root of this, that goes there. The cube root of this, that goes there. Now we square this, that goes there. We multiply these two together, that goes there. And you might say, well, shouldn't it be a positive? Again, we have that other rule. Whatever the sign is there goes with the two terms. The middle term here is always the opposite sign. So that prevails. And then we square this term, and that becomes a positive. Now, if this were a negative here, everything would be the same except this sign would be negative and this sign would be positive. Again, cube root, there. Cube root, there. Square this, there. Multiply these together, there. Square this, there. Again, practice and following what we've shown in the flip classroom lesson. All right, for number 10 now, we want to see what we can factor out of this. And looking at the number part, well, we could take a 4 out of everything. Now let's just do the number part. Then there'd be a 3 left here, a plus 1 that we wouldn't write here, and a negative 3 there. Okay, now for the letter part, x to the 3rd, x to the 3rd, x to the 4th. So what's the greatest power of x we could take out of each one? And that would be x to the 3rd. Now here there's a y. There's no y there, so we can't take out a y. So let's just finish this up then. So we took out the x to the 3rd and the number here, so this is just left with a y. Here, this is just going to be a 1 now. I have to put that 1 there. This is going to be a negative 3xy. Now, the key to these is that when you look at what you've factored out, there are no more common factors left inside this part in the parentheses. Okay, that one's completed. Now, this one I looked at, and they're asking us to factor the following algebraic expression. And what's common here? Well, out of both of these, we could take out a y to the negative 1. And that would leave here a 7 plus 2y to the negative 7. Now, I'm not sure they'll allow negative exponents. That would be 1. And then, to convert this would be 1 over y to the 7th, like so, plus 2 over y to the 7th, like so. So now we don't have negative exponents anymore, but maybe this is all they wanted. Okay, this will be sort of a short lesson. You're going to be doing your own practice and certify. And again, you want to master the skills. So when it's time for your test, you do well on it. Okay, this will wrap up Chapter 1.